The world beneath the waves has always held a sense of mystery and intrigue. But what happens when we decide to venture into this uncharted territory and attempt to construct something truly remarkable? From underwater cities to oil rigs, the depths of the ocean have become a hub of human innovation. In this video, we will explore the fascinating question of how engineers make underwater constructions and unveil the incredible feats that have been accomplished beneath the surface of the water. But before we dive into the depths of this topic, make sure to hit that subscribe button so you don't miss out on any of our future videos. Also, please give us a thumbs up for more great content. Building underwater comes with its own set of challenges and limitations. Unlike traditional construction projects on land, engineers must contend with a myriad of obstacles such as crushing pressure, freezing temperatures, strong currents, and zero visibility. Despite these challenges, engineers have developed innovative methods and technologies to overcome them and bring their visions to reality. The first step in any underwater construction project is thorough planning and surveys. Engineers utilize advanced technologies such as sonar scans and underwater drones to map the seafloor and analyze the soil conditions, water currents, and seismic activity. This information is crucial for selecting the optimal location for the project and ensuring its structural integrity. One of the most common methods for constructing underwater structures is the use of caissons, are massive watertight boxes that are lowered into the water. Once submerged, the water is pumped out of the caisson, creating a dry walk space at the bottom of the sea. Within this enclosed space, engineers can work as if they were on land, constructing the desired structure without being directly affected by the water. Another technique employed for underwater construction is the use of cofferdams, are temporary dams built around the work area to keep the water out and allow engineers to work in a dry environment. This method is particularly useful for projects in shallow waters. As the construction progresses, the cofferdam is extended to enclose the entire structure, providing a barrier between the work area and the surrounding water. For larger structures such as underwater tunnels, a different approach is required. One way to construct underwater tunnels is through the use of immersed tunnels. This technique involves building the tunnel in sections on land and then floating it to the designated site for final assembly. The Channel Tunnel, which connects England and France, is a prime example of an immersed tunnel. In the case of the Channel Tunnel, the tunnel segments were constructed on land, floated to the construction site, and then sunk into pre-dug trenches one by one. Once submerged, the segments are precisely positioned and joined together, creating a continuous tunnel beneath the sea. Underwater welding is another critical aspect of underwater construction, particularly in the realm of oil rigs and pipeline construction. This specialized technique allows engineers to join metal structures together underwater using welding. However, due to the unique challenges posed by the underwater environment, a different approach is needed. Special equipment and techniques are employed to ensure proper visibility, pressure control, and safety measures to protect both the divers and the structure being built. With advancements in technology, new possibilities for underwater construction have emerged. Remotely operated vehicles, or ROVs, have become valuable assets in underwater construction projects. ROVs are unmanned vehicles that can be controlled remotely from the surface, allowing engineers to reach areas that are difficult or dangerous for humans to access. Equipped with cameras and robotic arms, ROVs provide precise and efficient solutions for tasks such as inspection, repair, and construction. In recent years, artificial intelligence, or AI, has also found applications in underwater construction. AI-powered systems can analyze data from various sensors and cameras to create real-time maps of the seabed and assist engineers in making informed decisions during construction. This integration of AI allows for greater precision, efficiency, and safety in underwater construction projects. Over the years, numerous examples of successful underwater constructions have left us in awe of human ingenuity. One notable example is the Burj Al Arab in Dubai. This iconic hotel, often referred to as the Sail of the Desert, is built on a man-made underwater foundation. Another remarkable feat is the Moses Project in Venice. The Moses Project involved the construction of movable barriers known as moses that can be raised to protect the city of Venice from devastating floods. These barriers are strategically placed in the Venetian lagoon and are activated when high water levels are anticipated. As we continue to explore and understand the depths of our oceans better, the possibilities for underwater construction become limitless. From underwater cities to offshore wind farms and pipelines, our ability to harness the resources and potential beneath the sea is ever expanding. If you enjoyed this video and want to learn more about other amazing engineering projects, stay tuned for more updates. Don't forget to leave a comment below with your thoughts or suggestions for future topics. Thanks for watching.